ideal gas law. So as we look through this problem, we'll see that there are a number of things that we'll have to do before we actually solve our problem. Let's take a look and read the problem, and we'll go through and determine what we have and figure out what we need to get in the end. So we know that we're working with the ideal gas law. So let us start with just writing down what the ideal gas law is. PV equals nRT. Okay? All right. So if I have an unknown quantity of gas held at a temperature of 922 degrees Celsius in a container with a volume of 0.0250 milliliters and a pressure of 4.26 times 10 to the 5 torrs, how many moles of gas is present? So we want to know how many moles of gas is present. Well, if we remember from a few slides ago that our temperature has to be in kelvins, our pressure should be in atmospheres, our volume should be in liters, and we're looking for the number of moles. So we can also use different values. We can use a different number for R, but let's keep it where we're using the value where we have atmospheres, liters, and kelvins. Okay, so for that value, we're going to have R is equal to 0.0821 liter atmosphere mole. Okay, all right? So we'll put that to the side for now. So what do we have? Let's say we're starting off, we said that our temperature T, right, is equal to 922 degrees Celsius. So first we have to change, so we've got our T is equal to 922 degrees Celsius. Well, if we remember over here, we've got to have kelvins in our answer. So we must convert this value of Celsius to kelvins. Anybody remember how to do that? You add 273 to any Celsius value, and we will end up with 1195 K. My pen is not. Here we go. All right, so that's the first thing. We are next given our volume, where we said here, our V, volume is 0.0250 milliliters. So our volume is 0.0250 milliliters, and we need to convert that to liters. So we know that for every 1 liter, we have 1,000 milliliters. So essentially, oh, this is a very small amount. Essentially, we can just take our decimal and move it 1, 2, 3 places. We get 0.000. So the volume will end up being 0.00025 liters, which is 2.5 times 10 to the minus 5 liters. Okay, so we've converted our temperature, we've converted our volume, and our pressure now is given in torr, and we know that we have to put that into atmosphere. So pressure, 4.26 times 10 to the 5 torr. And if we remember, we have 760 torr for 1 atmosphere. And we end up with 560 atmospheres. We put that into our calculator. Okay. So now now we're looking for what the number of moles are. So we've got to rearrange our ideal gas law so that we get our number of moles by itself. So if I start with PV equals nRT, well, I'm trying to get N all by itself. Okay? So how do we do that? Well, if I divide both sides by RT cancels out over there, and so we end up with N is equal to PV divided by RT. All right, now we just plug and chug. So we've got 560 atmospheres times, what's our volume? Our volume is, for ease of putting into your calculator, I don't like putting in exponents in my calculator, 0.00025 liters divided by our R over here, which is 0.0821. And don't forget about your units, because they're going to help us to cancel out at the end. Right? And then our final temperature, which was 1195 K. All right, let's see if we cancel everything out properly. So our atmospheres will cancel out. Our liters will cancel out. And our kelvins cancel out down here. And because we've got moles in the denominator of a denominator, it becomes a numerator. So our answer that we get here, we plug everything into our calculator. Remember, when you're putting things in your calculator, you multiply all the way across the top and divide all the way across the bottom. And we end up with 0.0000. Let's write this a little smaller so that I can get everything on. Well, I'll write it down here. So 0.000143 atmospheres. If we want, we can put this into scientific notation. 1.43. We've got to move our decimal place 1, 2, 3, 4 spots. So 1.43 times 10 to the minus 4, because it is it's a number that's less than 1. And there we go. Oh, let's see. Let's check our number of sig figs. All of our given amounts, we had 922 significant, no, I had 922, which is 3 sig figs. Here, I've got 3 sig figs. And what else do I have? Here, I've also got 3 sig figs. So our answer, we're correct, having 3 significant figures in our answer. Okay?